I'm standing in front of what looks like just another runway, but the aircraft that might one day take off from here represent a leap in technology as significant as the jump from propellers to jets. We're talking about hypersonic fighter jets. These aren't just slightly faster planes, they are aircraft capable of traveling at over Mach 5, that's 5 times the speed of sound, or more than 1 mile per second. At that speed, London to New York would take less than an hour. But the primary goal here isn't passenger comfort. It's about redefining military air superiority for the next century. The ability to strike anywhere on the globe in under an hour, evading existing missile defense systems, is a game-changing capability. It's a strategic advantage so profound that it has ignited a new high-stakes global arms race. Nations around the world are pouring billions into research and development, creating secretive prototypes, and building extraordinary testing facilities. This isn't science fiction anymore, it's the very real, very near future of aerial warfare. The race is on, and the finish line is a fully operational hypersonic platform. So, who is actually leading this incredibly complex and expensive race? It's not as simple as just looking at who has the fastest prototype. It's about infrastructure, research programs, and long-term strategic vision. Today we're going to look at the top 5 nations pushing the boundaries of what's possible, counting down the key players in the race to control the skies of tomorrow. This is a story of physics, engineering, and immense geopolitical ambition. It should come as no surprise that the United States is a major contender. They have in many ways been working on this problem the longest. American efforts in hypersonic flight date back decades, with projects like the X-15 rocket plane in the 1960s touching the edges of space and hypersonic speeds. That legacy of pushing the envelope continues today, but with a much greater sense of urgency. The focus isn't just on breaking speed records anymore, it's on creating reliable, reusable, and weaponizable systems that can be integrated into the existing military structure. A key part of this modern push was the Boeing X-51 Waverider. This was an unmanned scramjet demonstration aircraft, and its successes were a massive proof of concept for air-breathing hypersonic flight. Instead of carrying heavy oxidizer like a rocket, a scramjet scoops oxygen directly from the atmosphere at incredible speeds. The X-51 achieved sustained flight at Mach 5.1, proving the technology was viable. This data is now feeding into a whole host of new, often classified programs managed by organizations like DARPA, the Defense Advanced Research Projects Agency, and the U.S. Air Force Research Laboratory. The challenge now is moving from successful, but ultimately disposable test articles to something that resembles an actual fighter jet. Programs like DARPA's Hypersonic Air-Breathing Weapon Concept, or HAWC, and the Air-Launched Rapid Response Weapon, ARRW, are the next logical steps. While these are currently focused on missiles, the technology, material science, and control systems being developed are directly applicable to a future piloted or autonomous aircraft. The US is playing a long game, building a deep foundational knowledge base. They have the budget and the history, but the question is, are they moving fast enough? If the US is the established pioneer, China is the astonishingly fast challenger. In the last decade, China's progress in the hypersonic field has been nothing short of breathtaking, causing considerable alarm in Western military circles. They have demonstrated a clear national priority to not just catch up, but to leapfrog existing powers in this domain. This isn't a side project for them, it's a central pillar of their military modernization strategy, and they are backing it with immense resources and a focused, state-driven approach that is difficult to match. One of their most significant, and frankly intimidating assets, is the JF-22 wind tunnel located in Beijing. It's reportedly capable of simulating flight conditions up to Mach 30. This is an incredible piece of engineering. It allows Chinese scientists to test aerodynamic models, heat-resistant materials, and engine designs at speeds that are currently impossible to sustain in actual flight. It dramatically accelerates the research and development cycle, allowing for thousands of virtual flights without the cost and risk of launching a physical prototype. It's a powerful tool for ironing out the incredibly complex physics of hypersonic flight on the ground. Beyond the lab, China has also been conducting numerous and often successful flight tests. They have reportedly tested hypersonic glide vehicles, like the DF-ZF, which are launched on a rocket before gliding to their target at extreme speeds. There are also persistent rumors and satellite image analysis suggesting work on a combined cycle air-breathing aircraft, something that could take off, from a runway, accelerate to hypersonic speeds, and then land again. While official information is, as you'd expect, scarce, the sheer pace and scale of their activities suggest China is not just in the race. They might be setting the pace. Russia, inheriting the formidable scientific and military legacy of the Soviet Union, has always been a key player in advanced aerospace engineering. They have a long and storied history with rocketry and high-speed flight, and that expertise is now being channeled directly into the hypersonic race. Unlike the United States, which has focused heavily on air-breathing scramjet technology, Russia has taken a slightly different, and perhaps more direct, path to achieving an operational capability. Their primary focus, at least publicly, has been on boost glide and air-launched ballistic missiles that achieve hypersonic speeds. The country has already claimed to have fielded operational hypersonic weapons. The Avangard is a hypersonic glide vehicle that they say can be carried by an intercontinental ballistic missile, and the Kinjal, which translates to dagger, is an air-launched ballistic missile that can be fired from modified MiG-31 interceptors. By adapting existing rocket technology, Russia was able to field a functional hypersonic weapon relatively quickly, creating a new strategic threat. While these are missiles, not reusable fighter jets, they demonstrate a mastery of the core challenges: guidance, control, and material science at extreme velocities. Looking toward the future, Russia is also conceptualizing a true hypersonic aircraft. The most talked about project is the PAK-DP, also known as the Mikoyan MiG-41. This is envisioned as a hypersonic interceptor aircraft, a successor to the legendary MiG-31. Details are, of course, highly speculative, but the concept is for a craft that can reach incredible speeds and altitudes to intercept incoming threats, including other hypersonic missiles and satellites in low orbit. It's an incredibly ambitious project, and whether Russia has the economic resources to see it through to completion remains a major question. But their proven missile success shows they are a force to be reckoned with. India is a fascinating and increasingly important player in the global hypersonic race. While perhaps not possessing the sheer scale of the American or Chinese programs, India has a world-class space program, a sophisticated domestic defense industry, and a clear strategic motivation to develop these technologies. Positioned in a complex geopolitical neighborhood, the development of hypersonic capabilities is seen as a crucial deterrent and a symbol of its rising status as a major technological power. They are pursuing a two-pronged approach: robust domestic development combined with strategic international collaboration. A key element of India's strategy is its long-standing defense partnership with Russia. This collaboration has borne fruit in projects like the BrahMos supersonic cruise missile. Now, they are working together on the BrahMos 2, a hypersonic version of that highly successful weapon. This partnership allows India to leverage Russia's extensive experience and leapfrog certain developmental hurdles. It's a pragmatic approach that provides a faster route to acquiring a functional hypersonic missile system, gaining valuable technical knowledge and operational experience along the way that can be fed back into their own domestic programs. Simultaneously, India's Defense Research and Development Organization, or DRDO, is hard at work on its own indigenous projects. They have successfully tested their own hypersonic technology demonstrator vehicle, the HSTDV. This was a crucial milestone, proving their capability in scramjet propulsion and high-speed aerodynamics. The plan is to use this technology to develop autonomous hypersonic cruise missiles and, eventually, a reusable launch vehicle. India's path is one of steady, deliberate progress, building a solid foundation of domestic expertise while using partnerships to accelerate near-term goals. They are a serious contender, not to be underestimated. While individual European nations might not have the colossal budgets of the United States or China, it would be a mistake to count them out. France, with its powerful aerospace industry and independent nuclear deterrent, is leading a significant pan-European push into the hypersonic domain. Their approach is one of collaboration and strategic foresight, aiming to ensure Europe does not fall behind in a technology that will define the next generation of defense. The French vision is not just about a single weapon, but about building a complete ecosystem of hypersonic technology. At the forefront of this effort is the VMAX, or Véhicule Manœuvrant Expérimental, a hypersonic glide vehicle demonstrator. The project, led by aerospace giant Ariane Group, is intended to help France master the complex technologies needed for flight at speeds above Mach 5. The first test flight was conducted in 2023, marking a major step forward. This isn't just a French project in isolation. It's seen as a pathfinder for a broader European capability, developing the skills, supply chains, and testing facilities that other nations can eventually plug into. It's about creating a foundation for European strategic autonomy. Looking further ahead, France is also spearheading conceptual work on a hypersonic interceptor to counter new and emerging threats. This project, currently in its early stages, is being developed in partnership with other European nations under the banner of the European Defence Fund. The idea is to develop a counter-hypersonic capability by the 2030s. This collaborative approach pools resources, shares risks, and ensures interoperability between allies. France is playing the role of a leader and an integrator, understanding that in this incredibly expensive and complex race, the collective strength of Europe may be the key to keeping pace with the superpowers. So, there you have it. The United States, China, Russia, India, and France are all locked in a race that is as much about physics and engineering as it is about national pride and global power. The development of hypersonic fighter jets and weapons isn't just an incremental improvement, it represents a paradigm shift in military strategy. The ability to hold any target at risk with just minutes of warning time fundamentally changes the nature of deterrence and conflict. It shrinks the globe and collapses decision-making timelines, creating a future battle space that is faster and more complex than ever before. This technology will force a complete rethink of air defense systems, command and control structures, and the very concept of air superiority. The countries that master this domain will hold a decisive strategic advantage for decades to come. The challenges are immense, from developing materials that can withstand searing temperatures to designing engines that can operate across a vast range of speeds. But the potential rewards are so great that no major power can afford to be left behind. We are truly witnessing the dawn of a new era in aerospace and defense. The outcome of this race is far from certain. Will the established research and development power of the United States win out? Or will the focused, rapid development of China allow them to take the lead? Perhaps Russia's early deployment of missiles gives them a head start, or maybe the collaborative efforts of India or France will produce a surprise breakthrough. The next 10 years will be absolutely critical. So, I'll leave you with this question to ponder in the comments below. Which country do you think will win the hypersonic race, and why?